Today, we will learn the standard form of numbers. Many times we encounter a number which is difficult to read and write. It becomes difficult to perform any operations also. In such a case, the standard form of a number helps us out. We can express any number n using exponent as m into 10 to the power of p, where m is equal to or greater than 1.0 but less than 10.0 and p is an integer. This form of a number is called its standard form. We also call it the scientific notation of a number. For example, we can write this number as 4.5 into 10 to the power of 6 in standard form. Let's find out how to find the standard form of a number. We can represent this number as 4.5 into 10 lakh. We can write this in exponent form as follows. Now, we see that the value of m is 4.5 and this number is greater than 1.0 and less than 10.0. Similarly, the value of p is 6, which is an integer. So, this is how we identify the standard form of this number. Now let us look at this number. We can represent this number as follows. We write this in exponential form as follows. Now, we see that the value of m here is 4.5, which is greater than 1.0 and smaller than 10.0. And the value of p is minus 5, which is an integer. In this way, it is the standard form of this number. Let us now find out how to write large numbers in standard form. Suppose we have to write this number in standard form. We have to represent it in the form of m into 10 to the power of p, where m is greater than 1 and less than 10.0 and p is an integer. For this, we will first place a decimal point on its right side. We can see that moving the decimal point 12 places towards the left, we get the number 3.45, which is greater than 1.0 but smaller than 10.0. In this way, 3.45 is the value of m. Since we moved the decimal point 12 places towards the left, we will multiply this number by 10 to the power of 12 so that there is no change in the value of this number. In this way, the value of p here is 12. This gives us the standard form of this number as 3.45 into 10 to the power of 12. Now let's find out how very small numbers can be written in standard form. Now if you are given a very small number of this type, then will you be able to write it in standard form? Give it a try. Let me tell you, we have to represent this as m into 10 to the power of p, where m is greater than 1 but less than 10.0 and p is an integer. We see that when the decimal point is moved 9 places towards the right, we get the number 8.76, which is greater than 1.0 but smaller than 10.0. In this way, we can write 8.76 in place of m. Since we have moved the decimal point 9 places towards the right, we will multiply this number by 10 to the power of minus 9, so that there is no change in the value of the number. In this way, the value of p here is minus 9. This gives us the standard form of this number as 8.76 into 10 to the power of minus 9. Today, we learned the standard form of a number. In the next video, we will see some interesting examples related to this. Today, we will see some interesting examples related to the standard form of numbers. If one day's food consumption of an elephant is 3 lakh gram, then how can you express 1 year's consumption of the elephant in standard form? Here, we have to write 1 year's consumption of elephant in the standard form. The standard form of a number is written in the form of m into 10 to the power of p, where m is greater than or equal to 1.0 but less than 10.0, and the number p is an integer. In one day, the elephant consumes 3 lakh gram. We know that there are 365 days in a year. So, we will multiply 365 and 3 lakh gram. In this way, 1 year's consumption of the elephant is equal to 365 into 3 lakh gram. We can write 3 lakh as 3 into 10 to the power of 5 in exponential form. In this way, 1 year's consumption of elephant is equal to 365 into 3 into 10 to the power of 5 grams, which is equal to 1095 into 10 to the power of 5 grams. We have to write the number in standard form. Therefore, we will place the decimal point on the rightmost side of 1095 and move it 3 places to the left. Since we have moved the decimal point 3 places to the left, we will multiply the number by 10 to the power of 3 to keep the value of the number same. So, 1 year's consumption of the elephant is equal to 1.095 into 10 to the power of 3 into 10 to the power of 5 grams. Can you tell us which exponential rule can we use to write it in simpler form? Think for a while. You got it right. We will use the rule a to the power of m into a to the power of n is equal to a to the power of m plus n. With the help of this, we can write 10 to the power of 3 into 10 to the power of 5 is equal to 10 to the power of 3 plus 5, which is equal to 10 to the power of 8. Using this, we can say that 1 year's consumption of elephant is equal to 1.095 into 10 to the power of 8 grams. Comparing this to m into 10 to the power of p, we get to know that the value of m here is 1.095, which is greater than 1.0 but smaller than 10.0. Similarly, the value of p is 8, which is an integer. Thus, by finding out the 1 year's consumption of the elephant, we have expressed it in standard form. Next example. The mass of a proton is 1.672623 into 10 to the power of minus 27 kg. And the mass of an electron is 9.109390 into 10 to the power of minus 31 kg. Compare the mass of both. We can compare them in different ways. We can determine which one has a higher mass among them. Similarly, we can also find out how many times is the mass of one greater than the mass of the other. Let's look at the first method. Which number is greater or smaller amongst the two exponential numbers? To find this out, we equate the units and exponents. Here, the units of both are the same. But for 1.672623 into 10 to the power of minus 27 kg, the power is minus 27, whereas for 9.109390 into 10 to the power of minus 31 kg, the power of this number is minus 31. To equate the exponents, we will either have to make the power of both as minus 27 or minus 31. Let's make the power of both as minus 31. Can you tell, in the number 1.672623 into 10 to the power of minus 27 kg, what do we need to do to make the power of this number to minus 31? Think for a while. Let me tell you. We will have to move the decimal point 4 places to the right, and to ensure that the value of the number doesn't change, we will have to reduce its power. Here, minus 27 is a negative integer. So, we will subtract 4 from minus 27 so that we get the power as minus 31. Now the mass of the proton is 16,726.23 into 10 to the power of minus 31 kg, and the mass of the electron is 9.109390 into 10 to the power of minus 31 kg. Since powers and units are the same, now we can compare them. Here, we see that 16,726.23 is greater than 9.109390. So, we can say that 16,726.23 into 10 to the power of minus 31 kg is greater than 9.109390 into 10 to the power of minus 31 kg. That is, the mass of a proton 1.672623 into 10 to the power of minus 27 kg is greater than the mass of the electron. Now let's compare these in terms of multiples. For this, we will divide the mass of one by the mass of the other. Mass of proton divided by mass of electron is equal to 1.672623 into 10 to the power of minus 27 kg divided by 9.109390 into 10 to the power of minus 31 kg. Try this division yourself. You can use a calculator. We will get the result of this division as approximately 1836.15. In this way, we can say that the mass of a proton is about 1836.15 times greater than the mass of an electron. Now, you can find out the mass of an electron in comparison to that of a proton. So today, we saw some interesting examples related to the standard form of numbers. In the next video, we will clear some misconceptions related to them. Today, we will see some misconceptions related to the standard form of numbers. Misconception 1. In the class, the teacher asks the students to write the number 0.000356 in standard form. Meena wrote the number as 356 into 10 to the power of minus 6 in standard form. Raj wrote the number as 3.56 into 10 to the power of minus 4 in standard form, and Rohit wrote the number as 3.56 into 10 to the power of 4 in standard form. Find out who wrote the number correctly in standard form. Some children are not able to understand the difference between the exponential form and the standard form of a number. They think that the exponential form of a number is the standard form. Like, we can write the given number in different ways like this. They can see that Meena's and Raj's answers are amongst these, so they think that option 3 is the correct answer. Since not every exponential form is the standard form, option 3 is an incorrect answer. Some children know that if the standard form of a number which is less than 1 is to be obtained, then the decimal point is to be moved to the right, so that the number can be written in the form of m into 10 to the power of p, where m is greater than or equal to 1 and lesser than 10, and p is an integer. For example, here Raj has moved the decimal point 4 places to the right, and to retain the same value of the number, multiplied it by 10 to the power of minus 4. So here, the correct answer is option 1. Some children do not correctly indicate the exponent sign while doing so. They think that a to the power of minus n and a to the power of n are equal. Like here, Rohit's understanding is that 10 to the power of minus 4 and 10 to the power of 4 are equal. But this is an incorrect understanding because 10 to the power of minus 4 means 0.0001 and 10 to the power of 4 means 10000. That is, option 2 is also an incorrect answer. Note that a to the power of minus n and a to the power of n are not equal. For example, 8 to the power of minus 3 is equal to 1 by 8 into 8 into 8, which is equal to 1 by 512, whereas 8 to the power of 3 is equal to 8 into 8 into 8, which is equal to 512. Do you think the result is same in both the cases? No. Therefore, a to the power of minus n and a to the power of n are not equal. Misconception 2. The grain storage capacity of tank A is 3 lakh gram and the grain storage capacity of tank B is 2 lakh kg. Compare the storage capacity of both the tanks. Here, the storage capacity of tank A is 3 lakh gram and the storage capacity of tank B is 2 lakh kilogram. The storage capacity of both the tanks is to be compared. Some children see that the storage capacity of tank A is 3 lakh, that is 3 into 10 to the power of 5, and the storage capacity of tank B is 2 lakh, which is 2 into 10 to the power of 5. The attention of the students does not go towards the units. Their focus is only on the number, like the number 3 into 10 to the power of 5 is greater than the number 2 into 10 to the power of 5. So, they think that the storage capacity of tank A is higher than the storage capacity of tank B. That's how they choose option 1, which is incorrect. We must focus on the units of the numbers. Here, the grain storage capacity of tank A is in grams and the grain storage capacity of tank B is in kg. Both the numbers must be in the same units for comparison. We know that 1 kg is equal to 1000 grams. That is equal to 10 to the power of 3 grams. Hence, 2 into 10 to the power of 5 into 10 to the power of 3 is equal to 2 into 10 to the power of 8. That is, the storage capacity of tank B is 2 into 10 to the power of 8 grams, which is greater than 3 into 10 to the power of 5 grams. So the correct answer is option 2. Today we saw some misconceptions related to the standard form of numbers.